Okay, so welcome to section 4.8, complex numbers, and this is just part one of this section. Okay, so let's start off with a little review. We want to find the zeros of this function. We have f of x equals x squared plus 1. So when you're finding the zeros, you got to make sure your function's equal to 0. Alright, so I have x squared plus 1 equals 0. I'm going to go ahead, subtract my 1, solve it. So I get x squared equals negative 1. You're thinking, alright, now I'm going to take the square root of both sides. So x is equal to positive and negative the square root of negative 1. But what happens when you go to type the square root of negative 1 in your calculator? You're going to see that it reads error. You cannot have negatives underneath the square root sign. And that is why we now have imaginary numbers, to prevent this error. So the imaginary number got started when we had the square root of negative 1. And that's exactly what it represents. The square root of negative 1. And we call this I. I is going to represent the square root of negative 1. And it's the same thing as pi. Pi represents a value. E represents a number. You have all these letters that represents values, and that's no different than I. Okay, so what we're going to do is if you have, let's say, the square root of negative 7. We're going to show you how this works. First of all, we know that 7 itself is a prime number. It cannot be broken down. But you don't want to leave a negative number underneath the radical, so you do need to break down the square root of negative 7. And how you break that down is you split it into negative 1 times 7. Okay? Well, now this is really the square root of negative 1 times the square root of 7. We have a basis in that represents the square root of negative 1, and that is I. So when you see the square root of negative 7, you really think, oh, it's I times the square root of positive 7. Okay? You don't want to leave negative numbers underneath the radical. You want to simplify them and break them down. Now, imaginary numbers are also very interesting, the fact that there's a pattern with them. So let's talk about what that pattern is. So I already told you that I represents the square root of negative 1. Which we never write the square root of negative 1, we always leave it as I, or I to the first. Well, what do you think we have if I have I squared? Alright, so I'm going to go up above here and I'm going to square I. So I have the square root of negative 1, but I want to square that. So that really becomes, whoops, let me find my eraser. So that really becomes, when you square something that's underneath the square root and the squaring are inverses. So you're really left with just negative 1. Okay, well what about I cubed? Isn't I cubed the same thing as I times I squared? Sure, because when I multiply things together with the same basis, I just add their exponents. So we all know that I is I, and we know that I squared is negative 1. And anything times negative 1 is the opposite of itself. So I have negative I. What do you think about I to the 4th? How can I get I to the 4th from the preceding terms? Well, I could do I squared times I squared. That's one way. Now I squared is really just negative 1 times negative 1. So now I'm up to positive 1. So far I have I, negative 1, negative I, positive 1. Let's see what we get when we have I to the 5th. Well, can I just do I squared times I cubed? That would be 5 i's that I'd be multiplying. And I squared is negative 1. I cubed is negative I. So I have two negatives and I'm left with positive I. Well, we've already had positive I before. So is this the start of my pattern? I'm going to let you guys, in your own time, try to tell me what the pattern is. What do we get when we have I to the 6th, I to the 7th, I to the 8th? See if you can find that pattern and let me know tomorrow. Okay, now let's go ahead and practice with i's, and we're going to express each number in terms of I. So we need to simplify. This is example 1a. So I have the square root of negative 121. Well, like I said before, you cannot leave negatives underneath the radical sign. So we're really going to break this up into negative 1 times 121. And that product is now underneath the square root. If you wanted to go a step farther and say, okay, this is really the square root of negative 1 times the square root of 121, you can also write this step too. Now we know the square root of negative 1 is I. And we also know that the square root of 121, that's 11. 121 is a perfect square. So when we write our final answer, we're going to write it as 11i. Okay, let's try example 1b. So now we have 2 times the square root of negative 25. Let's put a coefficient other than 1 in front of the radical. It's not going to change how you're going to break it up. And now it just becomes this 2 times the square root of negative 1 times 25. Okay, so let's now go ahead and do each one separately. 2 is going to stay with us. The square root of negative 1 is I. And what about the square root of 25? You're thinking 5. So you have 2 times I times 5. Let's multiply them all together, and we get 10i. Okay, so let's use that knowledge that we talked about when we simplified radicals with negatives, and we're going to use that to solve equations now. Example 2a. We have x squared equals negative 144. So you're going to, we're already in the process here of isolating for x, and so now all we need to do is just take the square root of both sides. But we're taking the square root inside of an equation, so you need to make sure you have your plus or minus. Now, the square root of negative 144, negative 144, you need to break that down into negative 1 times 144. So what is the square root of negative 1? You should all have this memorized. You're thinking, it's I. It's going to represent that imaginary number, whatever that value is. And the square root of 144 is 12. So we're going to write our final answer as x equals plus or minus 12i. Okay, now for example 2b, you have 5x squared plus 90 equals 0. I want you to solve and then show me the next class period. So we started this lesson talking about what an imaginary number is, and now we're going to continue it talking about what a complex number is. A complex number is any number in the form a plus bi. So we see that I again, that imaginary part. So a complex number contains a real value, a real number, and an imaginary number. As long as, I should put on here, b is not 0. Okay, because if b was 0, then it's just a real number. So an example of a complex number might look something like 5 plus 3i. Okay, 5 is my a value, it's my real part, and 3 is my imaginary part, it's a coefficient of I. So 5 plus 3i. Or maybe you just have 10i. Every imaginary number can be written as a complex number. In this case, our real part is just 0, because 10i is really 0 plus 10i. So 0 is my real part, and 10 is my imaginary part. Okay, we're going to use complex numbers and we're going to perform some operations on them. So looking at example 3a, we have 7 minus 2i plus negative 3 plus i. So we have two complex numbers here, and our operation for how we join them is going to be addition in this case. So if you're going to add complex numbers together, you add their real parts plus their imaginary parts. Or the real parts are added together, then the imaginary parts are added separately. So let's see what that looks like. First of all, if we're doing addition, you can really just drop your parenthesis signs. 7 minus 2i plus negative 3 plus I. And I can go ahead and combine my like parts. So I have 7 and negative 3, those are the real parts for each complex number. So 7 plus negative 3 is 4. Now for the imaginary parts, you have negative 2i plus I. Well, negative 2 plus 1i is really negative 1i. So my final result is 4 minus I. Okay, let's try B. B is going to add 1 plus 5i minus the complex number of 3 minus 2i. Okay, now when you're doing subtraction, and again our complex numbers are in parentheses, you really need to make sure that every part is being subtracted. So when I go to get rid of my parentheses, I have 1 plus 5i, but I need to subtract each part inside that parentheses. So when I subtract a positive 3, it becomes minus 3, and when I subtract a negative 2i, it becomes positive 2i. It's almost as if you're distributing that negative 1. You're taking the opposite of everything in here. And now I can go ahead and combine my like terms. 1 minus 3, we get negative 2. Then you have 5i plus 2i. And so I get 7i. And there's my final answer. So along with addition and subtraction, you can also do multiplication and division, which we'll get to later, with complex numbers. Example 4, we're going to find the product. So we're going to do multiplication. We have 7i times the quantity, 2 plus 5i. So what property are you thinking there that we need to use in order to get rid of those parentheses? You know, everything inside here, 2 plus 5i, each of those terms needs to be multiplied by 7i. So if you are thinking the distributive property, you are correct. I'm going to take 2 times 7i, and really remember, you can kind of treat that I as an x, just a regular variable. Okay, so I'm really multiplying the coefficients together. 7 times 2 is 14, so I get 14i. And then I'm going to take 5i times 7i. Well, 5 times 7 is 35. And what do you get when you multiply something by itself? Well, it becomes quantity squared. I times I is really I squared. Okay? Now, think back to that pattern that we talked about earlier. We said I to the first is I second is negative 1, I cubed is negative I to the fourth was positive 1. It's, you know, a little trick that I helped to remember that was taught to me. I won with 2 negatives in the middle. I won with 2 negatives in the middle. I won. Okay, so maybe that might help you when you go to think when you have to reduce powers of I. All right, so we don't want to have a power of I greater than 1 left in our final answer. Otherwise, if we do, we need to simplify again. We have an I squared. Well, I squared is really negative 1. So what we're going to do is replace I squared with negative 1. So instead of 35 times I squared, it's going to become 35 times negative 1. This is going to change our final answer to 14I minus 35. Now it's very common to write your real part first, so I'm going to put negative 35 plus 14I. So I have my real part first, my imaginary part second. And there's my answer. Okay, for example 4b, in your notes you have 2, oops, let me erase that, 2 minus 3I times the quantity 4 plus 5I. Okay, I want you to try to do this one. And we'll check your answer in class the next day. But now, as you go through and you do this multiplication, think of what it's like when we had two binomials that we multiplied together. Let's say x plus 3 times x plus 5. You know, what happens when you're multiplying two binomials together? What was that process that we did? What was that called? So think about that, and you're going to apply that same process to two complex numbers. Good luck!